Right, the overall protocol for this is we're going to write down the calculator answer, then go back and worry about the Sig Figs. I'm going to continue by writing down the calculator answer to each of these. By the way, make sure you know how to use your calculator and enter things correctly in scientific notation. If you constantly find yourself off by a factor of 10, it's because you're not using your calculator correctly. The scientific notation function on most calculators, the most common calculators, are either a button that says psi, EE, or a single button that says something times 10 to the end. In any event, make sure you know how to use your calculator. Now I'll go ahead and write down the calculator answer to each of these problems, and we'll go through a discussion of Sig Figs. So we have our calculator answer now. Now we worry about the Sig Figs. And here is how we determine the Sig Figs. We convert all the exponents to the same power of 10 as our calculator answer, and then apply addition-subtraction rules as normal. And remember, addition-subtraction is going to be focused on decimal places. All right, this first number here. We want to convert both of these numbers to the same power as our answer, which is 10 to the 5th. So we want to convert this number here to some number multiplied by 10 to the 5th. So to get to 10 to the 5th, we're going to have to multiply this part of the number times 10. We cannot change the overall value of this number. So if one side of the number, one half of this number, is multiplied by 10, we have to divide the other part of the number by 10 so that we are not changing the overall value of this number. So this number comes out to be 0.23 times 10 to the 5th power. And to that, we're going to add 4.5 times 10 to the 5th power. And what we see is that as far as decimal places, we're limited to 1 decimal place. Okay, this number here has 2 decimal places. This number has 1 decimal place. We have to convert both of these numbers to the same power in order to compare decimal places. So 1 decimal place is what we're limited to. So our final answer is 4.7 times 10 to the 5th power. And I see here that there's a mistake in this version of the handout, so make note of that. But the correct answer is 4.7 times 10 to the 5th power. So a reminder, each number written in scientific notation has 2 parts. It has the exponential part, and it's going to have a part that's associated with the coefficient. Let's look at the calculator result of the second problem. We see its exponent is -3. So we want both of our numbers that go into this result to have exponents times 10 to the -3. So in order to accomplish that, we're going to have to multiply this exponential times 10. Again, we cannot change the overall numerical value of this, so we need to divide the other half of that number by 10. Okay, we rewrite the numbers, lining up the decimal point, and the result is that we see that we can justify 2 decimal places. If we have 2 decimal places in the result, that means overall we're going to have 3 Sig Figs. So 3 Sig Figs here means that our final answer is going to be 1.31 times 10 to the -3. Our third example, we see the calculator answer is times 10 to the 9th, positive 9th. So we want both of our values that go into that result to be expressed to the +9 power. That means this portion of the second number needs to be multiplied by 100, because 10 to the power 2 is 100. That means this side of the problem, the number needs to be divided by 100. We're going to have to move the decimal 2 spaces. Rewriting, we have 8.115 times 10 to the 9th, and we're going to be subtracting 0.015 times 10 to the 9th. What that means in terms of decimal places is we see that we have 3 decimal places, which results in a number that has 4 significant figures. All right, let's look at our calculator answer. It has only 2 significant figures, so what we need to do is to add zeros. So when we add zeros to the end of this coefficient, we see that we have a number, a coefficient with 4 sig figs, which means the number has 4 sig figs, and it's multiplied by 10 to the 9th.